Good day everyone. In this video, we will present and demonstrate to you the AP12 RGB light dimmer. Before we start, here are the group 2 members again. Josh Valerie D. Palyarcuna, Jan Cedric Lahato, Christian Barwado, and Ashik Alsinawi. Is RGB light dimmer in Arduino. The RGB light dimmer in Arduino involves controlling the brightness and color of an RGB LED by adjusting PWM or pulse width modulation, values for the red, green, and blue pins of the LEDs. You can create various colors and dimming effects inputs like potentiometers like we use, or buttons or sensors are often used to vary the intensity of each color channel.
Here are the materials that we are going to use for this project. First is the Arduino board. It acts as the microcontroller to control the flow of current and provide power to the LED. Next is the breadboard, a platform used to build and test the circuit without soldering it. Jumper cables, used to connect different components on the breadboard or between the Arduino and the breadboard, allowing current to flow through the circuit. RGB 5mm LED. An RGB LED in Arduino is a special type of LED that can emit different colors by combining three primary colors such as red, green, or blue, and blue. 10K potentiometer. It is typically used to adjust levels in a circuit such as volume, controls, brightness adjustments, or any application where a varying resistance is required. 220R resistor. Limits the current flowing through the LED to prevent it from burning out. Here are the added components that we are going to use for our challenge. One buzzer and 2 pieces jumper cables.
Good day everyone. In this video, I'll talk about the instructions of how to assemble the AP12, and I'll explain step by step of how to break down the circuit. First is the RGB LED connections. The RGB LED has 3 color pins, red, green, and blue, along with a common cathode or depending on the LED type. In this circuit diagram, the GB and R lines are connected separately to 3 different pins on the board, which are likely connected to pins on the Arduino allowed to diming using analog. Next is the potentiometer connections. Each potentiometer has 3 terminals. The center pin of each potentiometer is connected to input pins on the board to read the analog signal. One side of each potentiometer is connected to 5 volts to provide a constant voltage, while other side is connected to the GND. This setup allows the potentiometer to act the voltage dividers, outputting a variable voltage based on the position of the knob. So in our challenge in AP12, we added the buzzer pin and has 2 connections. The black wire is connected to the GND rail and the green wire is connected to the 12 pin.
Hi everyone, in this video, I'm going to talk about how our code works in AP12. So, the variable int red pin equals 9, int green pin equals 10, and int blue pin equals 11. Designed digital pins 9, 10, and 11 for managing the red, green, and blue channels of an RGB LED. And int pot red pin equals 0, int pot green pin equals 1, and int pot blue pin equals 2 assign analog pins A0, A1, and A2 to potentiometer that adjust the brightness of the red, green, and blue color. The lines pin mode red pin output, pin mode green pin output, pin mode blue pin output set the RGB LED pins 9, 10, 11 as output to control LED brightness. Serial begin 9600 starts serial at 9600 allowing data to be sent to the serial monitor. Analog red pot red pin, analog red pot green pin, analog red, pot blue pin. These lines read the analog values from the potentiometer connected to A0, A1, and A2. Each reading is between 0 minimum 1023 maximum, representing the position of each potentiometer. Map pot grid 0 1023 0 to 55 maps the potentiometer readings 0 to 1023 to a range from 0 to 255. This is because the LED brightness control analog write accept value from 0 off to 255 full brightness. BAL1, BAL2, and BAL3 represent the mapped brightness value for the red, green, and blue channels. Serial print red and serial print BAL1 and the others in this code. This line sends the map brightness value for each color to the serial monitor for easy debugging and real-time feedback. Color RGB, BAL1, BAL2, and BAL3. This function calls send the map value to the color RGB function which adjusts the LED color by controlling the red, green, and blue channels. The function color RGB, int red, int green, int blue, adjusts the RGB LED based on the specified brightness levels for each color. The line analog write red pin constraint red 0255 sets the brightness for each color channel while using constraint to keep the value within the range of 0255 for precise and smooth adjustment. That's all. Hello everyone. In this video, I'm going to talk about how our code works in AP12 challenge. So, let's get started. In this line, int red pin equals 9, green pin equals 10, blue pin equals 11, digital pins for controlling the RGB LED. Int pot red pin equals 0, pot green pin equals 1, pot blue pin equals 2, analog pins for reading potentiometer inputs. Int buzzer pin equals 12, digital pin 12 to control the buzzer in Arduino. In this line, pin mode output sets up the RGB LED and buzzer pin so they're ready to send signal. Serial begin 9600 opens a communication channel to our computer or laptop in Arduino so you can see a value in the serial monitor which helps us with understand what's happening in real time. In this line, analog red, each line reads the value of a potentiometer, reads value range from 0 to 1023, and tell us how far each dial is turned. Next is map. This function scales the potentiometer values 0 to 1023 to a brightness range 0 to 255, suitable for controlling LED colors. So BAL1 and BAL2 and BAL3 represent brightness for red, green, and blue respectively. If BAL1 red brightness is 255 equivalent to max, it lights up the LED in pure red. If BAL2 green brightness is 255, it lights the LED is in green and triggers the buzzer with a 500 milliseconds on or off cycle. If BAL3 blue brightness is 255, it lights the LED in blue and triggers the buzzer with a shorter 250 milliseconds on and or off cycle. This conditional statement checks each potentiometer and change both the LED colors and the buzzer state based on the specific value of BAL1, BAL2, or BAL3. Serial print read. Serial print BAL1 and the others in this code. Blue and green, this part shows the current brightness levels of red, green, and blue on the serial monitor, which is useful for tracking the LED colors. Void color RGB, int red, int green, int blue, analog right, red pin, constraint, red 0255, analog right, green pin, constraint, green 0255, analog right, blue pin, constraint, blue 0255. This function takes three values, red, green, blue, and adjusts the LED brightness accordingly constraint. Ensure the value stays within the 0 to 255 range for smooth LED control. That's all. Thank you.